Well, once again, good morning, good afternoon, or good evening, Algebra Geometry 3 classes. We are closing in on the end of Unit 6 now, and the topic we're going to look at for it are some real-world applications of absolute value, and that involves what's called either allowable error or tolerance. And in many applications, a lot of times it's production. When you go and buy a product, it will actually have a weight range, and that's what's called the maximum acceptable deviation for a product from some ideal or average measurement is what's called the tolerance. So when you are dealing with absolute value, you can have the actual weight of a product minus the ideal weight of the product. Now, the reason why we have to use absolute value, it's possible that when you take the actual weight minus the ideal weight, it is going to be below the ideal, and so that's why we need the absolute value. Or we take the actual weight minus the mean of extremes, and when we say mean of extremes, remember, mean represents the average. So there are two different styles of these questions that you are going to see in this unit. So, first one says a food manufacturer specifies that every family-size box of cereal should have a net weight of 25 ounces with a tolerance of 1.2 ounces. Write and solve an absolute value inequality that describes the acceptable net weights for the cereal in the family-size box. And so this is where right now, if you went to the grocery store, bought the same exact type of cereal, there's a good chance not every box is going to weigh the exact same. And that's what this tolerance represents. So, when it says it should have a weight of 25 ounces, this is our ideal, meaning what it should weigh. So what we're going to do, set up our absolute value, and we'll just use A minus the ideal weight is 25, has to be less than or equal to 1.2 ounces. Now, as you've worked through 6.3, when you solve absolute value, you solve one of them with it exactly as is. For the other one, we're going to solve greater than or equal to negative 1.2. So for these, all we're going to do, add the 25 over. So it has to be less than or equal to 26.2. Has to be greater than or equal to 23.8. And so then the other thing that you are going to usually do when you enter these answers in, 23.8 is the minimum of our interval, 26.2 is the maximum. Because they are less than or equal to and greater than or equal to, we will use brackets on those. All right, now the next question has a little different style. It says a 16-ounce bag of flour doesn't weigh exactly 16 ounces. Suppose the actual weight can be between 15.6 and 16.4 ounces inclusive. Write an inequality that describes the acceptable weights for a bag of flour here. Well, these are what are called your extremes, meaning this is the minimum, this is the maximum. So to find the ideal, we take the max plus the min, divide by 2. Again, that's when we say the mean of the extremes. So I'm going to take 15.6 plus 16.4, divide by 2. Well, when I add these up, that is 32, divided by 2 is 16, which matches that number. Now, the other thing that we have to find is our tolerance. To get your tolerance, you take the max minus the min divide by 2. So for this, what's going to end up happening is 16.4 minus 15.6 divided by 2. Well, when you enter these in, that is 0.8 divided by 2 is 0.4. So unlike the last one, you are not going to actually solve an inequality. We are just going to write an inequality. And we're going to use these two numbers. Here was our ideal. Here was our tolerance. So what I'm going to do, since I'm at the bottom of the page here, our inequality, we're going to take A minus 16 absolute value less than or equal to 0.4. The reason we are not going to make you solve this one is you've actually already, been given these two numbers. So that is where we're kind of working backwards, but that is your inequality there. All right, example 3 is similar, except now they have not told you what the ideal should be. So it says you found that your new winter coat is comfortable to wear when the outdoor temperature is between 10 degrees and 42 degrees Fahrenheit inclusive. Write an absolute value inequality for this temperature range where T represents the temperature in degrees Fahrenheit. So basically now what we are going to do for these is simply, again, here is our minimum, here is our maximum. So to start, we are going to find our ideal. So we're going to take 10 plus 42 divided by 2, which is 52 divided by 2, or 26 degrees. Then we are going to find our tolerance. To find your tolerance, you take the max minus the minimum divided by 2. Well, 42 minus 10 is 32, divided by 2 is 16 degrees. So now the only other thing that you are asked to do is write the absolute value inequality. So here we can just say absolute value of the actual minus our ideal is 26 has to be less than or equal to 16. So for the final examples, and this is a great spot where as you're doing any of these, if you do want to actually, using this table, come in and, pause the video, find any of them on your own, you can. Because again, basically what they've done is they've given you your minimum, they've given you your maximum. So we're just going to set up inequalities for each. So for the volleyball, again, start out finding what's the ideal. 260 plus 280 divided by 2 is 270. We also need to find our tolerance. 280 minus 260 divided by 2. Well, 280 minus 260 is 20, divided by 2 is 10. So for this one, the actual minus the ideal, 270, has to be less than or equal to 10. Now, as I work through these, I'm going to keep our table handy. And next up, basketball. Again, to start, we're going to find the ideal. So 600 plus 650 divided by 2, that's 1250. Divided by 2 is 625. For your tolerance, again, you take the maximum minus the minimum, divided by 2 is 25. Now, from there, when you set up your inequality. Again, we'll take the actual minus the ideal. Has to be less than or equal to 25. All right, up next, water polo. Again, has to be between 400 and 450 grams for the weight. So our ideal, we're going to average those, 400 plus 450 divided by 2. Well, when you take 850 divided by 2, that's 825. For your tolerance, 450 minus 400 divided by 2 is actually just like the one up above, because that's 50 divided by 2, 25. So for water polo, absolute value actual minus the ideal, and actually that should be 425. I think I didn't divide the 8, I only divided the 50. So minus 425 is less than or equal to 25. All right, lacrosse, a little bit smaller there. So when you work with it, ideal, again, we're going to take the minimum plus the maximum divided by 2. That is 291. This one is going to even end up as a decimal. Not a problem if that happens. Actually, when you deal with tolerance, that's a fairly common thing to have. All right, for the tolerance, 149 minus 142 divided by 2. Well, that's 7 divided by 2 is 3.5. So your inequality here, the absolute value of the actual minus the ideal has to be less than or equal to 3.5. And then the final one, the football, has to be between 14 and 15 ounces. So 14 plus 15 divided by 2 is 29 divided by 2 is, again, 14.5. So here's another one. Does end up giving us a decimal value for our tolerance. 15 minus 14 is 1. Divided by 2 is 0.5. So our final inequality there, we're going to take the actual minus, again, the ideal, which is 14.5, has to be less than or equal to that tolerance value. So again, this is the second to last section in Unit 6. There is a Schoology assignment for 6.4.